We're going to go into the connections that you just arrived at in part C of the discovery. But before we do so, it's important to just remind ourselves of some vocabulary from previous years and perhaps learn a few new terms that we're going to be talking about an awful lot over the next few lessons. So for starters, we have a positive function. Okay, what does it mean for a function to be positive? Well, it is above the x-axis. In the same way that a negative function is below the x-axis. So a negative function is down there, whereas a positive function would be up here. And all we are concerning with is whether the function is below or above the x-axis. We can have a function which is both positive and negative. That's fine. It's positive when it is above the x-axis and negative when it is below the x-axis. An increasing function is one in which the y values get larger as the x values get larger. All right, so we're heading up. Okay, basically we're talking about a function which is going up as we move to the right. But in essence, the y values become larger as the x values grow. And a decreasing function is the opposite. Instead of the values becoming larger, they'll be becoming smaller. All right, so the y values become smaller as the x values also become smaller. Now, an extreme value is one in which we are at the highest or lowest point. So an extreme value is the top of the hill or the bottom of the valley. Okay. And more specifically, we can break this category of extreme value down into either a maximum or a minimum. So a relative maximum, which is also sometimes called a local maximum, you can use these two words interchangeably. It doesn't matter if you say relative max or local max. But that is the top of the hill. Okay. So if we're talking about a function which increases and then decreases, the spot where we get the absolute top of the hill, okay, that is our relative max. Okay, right at the top. And the local min, or the relative min, that's going to be the bottom of the valley. Right, that point right there. That is our relative min. So combined, the local maxes and the local mins make up the extreme values. In the same way of saying the extreme values can be split up into relative maxes and relative mins. Now a critical number, right, or a critical point, so a critical number means x only, but a critical point means x, we actually have the x and the y. But a critical number, critical point, that's where the relative min or the relative max is going to occur. Well, what happens at a relative min or relative max? Well, the derivative is either going to be equal to 0 because we know the derivative is the slope of the tangent to the curve, so we have a horizontal tangent line, or we might have a situation where we go up and then we drop. Now that is a corner or a cusp. It's also the top of a hill, top of a mountain if you prefer, and that is the spot where the derivative does not exist. So a critical number, and this is important to know, a critical number occurs when the derivative equals 0 or does not exist. All right, when the derivative equals, when the derivative equals 0 or does not exist, That's known as a critical number or critical point. Concavity. Concavity means curvature. So when we are talking about something being concave up, it means it is U-shaped. That is a concave up function. A concave down function, as you can imagine, is upside down U-shaped, like so. So this is a function which is concave down. A point of inflection or inflection point is where the function changes from concave up to concave down or vice versa. So this is a point where concavity changes. So, for example, here's a function which is both shaped like a U and an upside down U. And at the spot, somewhere right around there, where we change from a U-shaped curve to an upside down or vice versa, that is your inflection point. A possible point of inflection is like the critical numbers from up here. A critical number is when the derivative equals 0 or does not exist. A possible point of inflection occurs when the second derivative equals 0 or does not exist. So a possible point of inflection is to the second derivative what a critical number is to the first derivative.